Okay. All right. So, talking about graphing functions, a linear equation is an equation whose graph is a line, right? It's kind of obvious by the name linear, has line actually in the word line. Line equation is an equation whose graph is a line. And we can use a table of ordered pairs to graph an equation, right? We can input an x, we can get an output of a y, plot those coordinate points on a graph or on a coordinate plane, draw the line that connects all those points together, right, and wind up with the graph of our function. So to determine if the graph represents a function, we use a vertical line test. How many of you are familiar with a vertical line test? Okay, good. So if a vertical line crosses it more than once, crosses my line more than once, is it a function? No. Okay, so if it crosses it just once, it's a function. So if a vertical line intersects the graph at more than one point, it's not a function. A linear function is a function whose graph is a line, just not a vertical line. Okay. A linear function can be written in the form of f of x equals mx plus b, or y equals mx plus b, where m and b are real numbers. I think we're familiar with most of that information. Okay. That appears to be it. Those are your notes, right? We knew that, correct? We knew this information. All right, so let's check and see what types of questions we can answer. I don't know what that is. Go away. Okay. So the rest of this is just talking about those graphs and what those graphs look like and what different parts of it we can determine. So here it says identify the range of the function shown in the graph. What is range? What set of values does range involve? Is it my x values or my y values? Y values. Y values are going to be on which axis? The y axis, the vertical line, correct? Okay. So we're looking for the range. And so you'll notice with this curve, now is this a function? Yeah, because if I draw, vertical lines, right, they all cross only just one time. Okay, so that works. All right. So my range has a maximum. Do we see that? It only goes up to a certain point, but does it go down forever? All right, so it's less than something, and in fact, because it's a solid line, it's less than or equal to something. What is it less than or equal to? 4. Good. Less than or equal to 4. Now, if we were asking for the domain, we'd be looking for the x values, right? So the domain in this case, or x, because it goes on and on forever to the left and to the right, x is less than or equal to infinity, positive, and negative infinity, because it continues to go on and on. In fact, what we could say is that in terms of our domain, x equals all real numbers. Okay? But our range does not. Our range has a limitation. Our range is less than or equal to 4. Do we follow all that? Okay. Great. All right, let's look at the next question. Which function is represented by the graph? Well, let's see. I'm going to kind of scroll up here, and I know that you got it in front of you. You can look. But let's see if we can come up with the equation of this line without a list of possible options. Right? We could start off with y equals. What's typically the first thing we look at when we look at the graph of a line? Where do we start from? Do we start with the slope? Or do we start with the y-intercept? There's really only two parts. All right, so what is the y-intercept here? -2. Do I put, it's what, -2x then, right? Oh, so it's -2 over here, right? Okay, so we're at -2. What am I going to do from there? Up to, up 1 over 1. It's the same thing, right? Up 1 over 1. So what is the slope of this? Just x. Y equals x minus 2 or 1x minus 2. Either way. Okay. Let's see if that gives me an option. It looks like A, right? Okay, good. Okay, identify each graph as being nonlinear, a nonlinear function, a linear function, or not a function. Graph A, what is that? Is that a function? Is it linear? So it is a what? Nonlinear function. Very good. What about graph B? Is that a function? Okay, is it linear? So we would call it a linear function. Very good. Graph C, is that a function? How could I test? Yep, does not pass the vertical line test. Okay, so we're going to say what? Not a function. Okay, so we should again, let's see, we got nonlinear function, okay, which is A, C, and D. Then we get linear function, so that gets me down to C and D. And then we have not a function, which just brings me to D, right? All right. All right. Let's see. Graph the equation. So we want to pick the correct graph for the equation y equals 5x minus 4 and tell whether it's linear. Where do I start from? The y-intercept. So I want to be where on the y-axis? Negative 4. Okay. Should this be linear? Look at the equation. Is that linear? Yeah. And on like question D is quadratic. Quadratic equations have a parabolic shape to it, have a curve. Okay? So from what were we at? Negative 4. Let's go up 5. 1, 2, 3, 4, 5 over 1. That appears to be what we want it to be, right? Okay, so B is our answer. We feeling like these are pretty easy? Okay. Now, question number 5. We want to get the domain and the range. Okay? Domain refers to what? The x values. So, looking at this with the idea that these are going to go on forever left and right, correct? Okay? My domain is what? All real numbers. Good. Okay? But my range or my y, does it have a minimum or a maximum? Has a minimum. All right, because it has a minimum, is it going to be less than or equal to or greater than or equal to? Greater than, because from here it goes up. Greater than or equal to what? Negative 5. We look for the y part of that. Y is greater than or equal to negative 5. Do we see, I think we see that with C, correct? Okay, I think so. C is our answer. Okay, getting into more wordy type problems. The linear equation, y equals 70x. What does that mean for my y-intercept? Starts at the origin. So we can already tell that A is wrong, correct? Because it has a y-intercept of 70. All right, what else do we know is wrong? B is wrong. It also has a y-intercept of 70. So we want to get between C and D for my option. See how quickly we eliminate things when we know just a little bit of information? The linear equation y equals 70x describes how far from home Shu Ling is as she arrives from New York to Kansas City. Well, that's kind of cool. They don't usually include Missouri in things. Let x represent the number of hours and y represent the number of miles. How far from home is Shu Ling in 12 hours? Remember, x represents number of hours. So what are we going to do with this? We get y equals 70, right? If she lives 12 hours away, we would do what? 70 times 12 would give me the number of miles. All right, what's 70 times 12? What did you say? So y equals 840. So if we look at 12 miles, right? We should find, I'm sorry, number of hours. So yeah, if we look at 12 hours, we should find 840 miles, right? Okay. So far, just in the writing, C looks correct. Shuling is about 840 miles from home in 12 hours. What does D say? Does D say the same thing? No, Shuling is about 12 miles from home in 12 hours. That would mean that she's only driving how fast? 1 mile per hour. That doesn't seem reasonable, does it? No, so we should be able to get C for our answer, and we can go ahead and take a look. All right, we're looking for 12 hours, a little over 800 miles, right? We see that show up right there, correct? All right, so do we understand how to use some of this information to correctly determine graphs? Okay. Let's erase that. Okay. All right. Identify the domain and range of the function shown here. Okay, number 7. Domain. Domain is what? X values, right? Okay. Okay, so let's look at our X values, our domain. Does it have limitation? Does it have any place where it stops? Where does it stop at? It stops at 0 and goes which direction? To the right. Okay, so to the right, is that greater than or less than 0? Greater than. And because it appears to touch 0, right? So what is my inequality in relation to 0? Is it less than 0 or greater than 0? Is it equal to 0 or not equal to 0? Okay, so my domain is that x is greater than or equal to 0. Okay, now let's look at our range. Range, y. Okay, does it appear to have a minimum or maximum? It has a minimum. All right, so what is that minimum? Yeah, let's go with the whole number. No, -2, right? It continues, it goes past -1 all the way up to about there, right? Do we see that? Okay, it gets close to the line, touches at -2. So is it going to be greater than or less than -2? Greater than. Okay, does it appear to touch it or get close to it without touching? Touches, right? One of the indicators that it would be just greater than is if we had like an open circle where it broke there. Okay, and we'll see that later on. Okay, so we understand our domain and range for those things with a graph that looks like this. Okay, all right. Okay, let's look at number 8. Use the graph to identify the domain and range here. Okay. My domain, x values, left and right. Does it have any limitations? No, so we're going to say what? All real numbers or all real values. Okay, what about my range up and down? Does it seem to have any limitations? No. So all real values or numbers. Okay? Makes sense. We understand that. We're getting close to the end here, and then you guys can get started. Let's see, number 9. Let's see, graph the equation. The y equals the absolute value of x plus 1. We'll use a table to decide whether, when we want to decide whether the graph represents a function, whether it's linear or nonlinear. Okay, so using a table of values, what would we want to, let's go ahead and list all the x values we want to plug in. But just to see, let's do this. Can we do -3, -2, -1, 0, 1, 2, 3? Okay, let's try that. Didn't help me out. Okay, I'll kind of shove 3 down. Okay. Okay, so looking at this, the absolute value of -3 plus 1, what does that come out to? What's the absolute value of -3? 3. What's 3 plus 1? 4. Okay. What's the absolute value of -2? Plus 1. Okay. What's the absolute value of -1? Okay, 1. 1 plus 1 is, beginning to see a pattern here a little bit, right? What's the absolute value of 0? Plus 1. Okay, what's the absolute value of 1? Plus 1. What's the absolute value of 2? Plus 1. What's the absolute value of 3? Plus 1. All right, so what you should see with your graph here is if we have -1, -2, -3, 0, 1, 2, and 3, right? And 1, 2, 3, 4 is at -3. I'm all the way up here, right? Right, that's where I'd graph that, approximately. -2, I'm at 3, something like that. -1, I'm at 2. At 0, I'm at 1. And then what starts to happen as I get to 1? I'm making a V. You're absolutely right. Well, not a triangle, an actual V that would continue to go up this way and up this way the more values I plugged in. Is this a function? Yeah. Okay. And is it linear? No, it's not linear. Okay. All right. So a graph represents a nonlinear function, and all absolute value graphs will be similar to that. Okay. In fact, later on we'll talk about parent functions, and this is the parent function of that, which gives you something that will look like this, because it will start at the origin and branch out. Okay. That was number 9. Question number 10, complete the table for y equals 3x squared plus 6. Okay, so we're going to plug this in. What's what's -1 squared? What's -1 squared? That's the same as -1 times -1. 1, right? What's 3 times 1? What's 3 plus 6? 9. So hopefully we understand that. If we need to, what's 0 squared? 0. What's 3 times 0? What's 0 plus 6? Okay. What's 1 squared? What's 3 times 1? All right. What's 3 plus 6? 9. All right. What's 2 squared? What's 4 times 3? What's 12 plus 6? All right. There we go. That should be it. Let's see. It says then graph. We would wind up with something. I think you'll see this in your answer key. As we wind up, because it's a quadratic equation, we're going to wind up when we graph that, something that looks like that. Okay? Questions? We understand this moderately well, enough to get started, enough to get to a point where if I had questions I could ask them. Okay. I'll let you go.